Hello and welcome to the 2025 International Virtual Science Symposium webinar. This is the second webinar in our series for the 2025 Globe IVSS. Today we'll talk about how to access data from the Globe database. And if you missed the first webinar where we provided an overview of the theme for this year and other guidelines for the 2025 IVSS, it is linked to the IVSS webpage, and I will show you how to get there in just a minute. So feel free to introduce yourself in the chat. My name is Allison Moat. I am an education specialist with the Globe Implementation Office, and I'm really excited for this year's IVSS. In the webinar today, we'll talk about the 2025 IVSS and theme and how it connects to the 30 Years of Globe campaign. And the real meat of our webinar is going to cover how to access Globe data, and I'll demonstrate how to do this using the Globe Visualization System, or GlobeViz, and the Advanced Data Access Tool, or ADAT. And then I'll also show you how to take the data that you can download from these two systems and import them into Google Sheets. And then we'll wrap things up by providing you with some additional resources to support educators and students and upcoming webinars. So the 2025 IVSS theme this year is 30 Years of Globe, Understanding the Past, Present, and Future. And we are so excited to see how students engage with this theme this year as they explore their local environment. These are some shots from last year's IVSS projects, and it's just such a joy to see students learning about their environment, collecting data, and analyzing data. If you are not familiar with the IVSS, we encourage you to check out that first webinar that's on our website. But it is an online symposium for students to share their Globe research with STEM professionals and the Globe community. So this is a great opportunity for students who are engaging with research projects to get valuable feedback on their work. We have judges who volunteer their time from all around the world, and they not only score student projects, but they also provide really great feedback to students to help them improve their work. And the Globe IVSS is open to all Globe students in primary through undergraduate grade levels. And we have different rubrics by grade level to assess or to support judges in providing feedback and scoring student projects. So this year we are very excited about our 30 Years of Globe campaign. We are celebrating Globe's 30-year anniversary. In the 30 Years of Globe campaign, we're encouraging people to engage with to compare Globe data past and present. So I've got a screenshot of the 30 Years of Globe website here and an excerpt of some of the text that's there. So this really sums up the theme this year, which is exploring past data alongside present data is important in measuring environmental changes at all scales and planning for the future. The purpose of this year-long campaign is to take a deep dive into the last 30 years of Globe data. Investigations exploring paired data collected in the past and now is particularly encouraged. So please visit the 30 Years of Globe campaign website. If you are going to be participating, we encourage you to fill out a participation form to let us know you're participating, and we encourage students and educators to get involved. Which brings us to the 2025 IVSS in celebrating Globe's 30th anniversary. So this year, we're encouraging students to get into the Globe database to really explore some of that data that's been collected over the past 30 years. There are over 250 measurements recorded in the database, which is just amazing, amazing work by the Globe community, which includes both students, educators, citizen scientists from all over the world. And there are a variety of ways students can use past Globe data as part of their IVSS projects. So hopefully this webinar will provide you with some ideas for that. But just some, ideas here as students start to engage with their IVSS projects or start their research projects. They could use Globe data to develop an understanding of Earth system processes. So maybe getting some of the background knowledge or building on their background knowledge using globe data. As students are getting started with their research projects, maybe they could use globe data or explore the visualization system or database to help them develop their research questions and hypotheses. As they get a little bit further along with constructing their explanations and putting things together, they might reference the Globe database and pull data to help them construct their explanations and using data to support their explanations. We also encourage students to use Globe data from any time period or region. So as students are looking at data that's in the database, they don't have to look at the full 30-year history of Globe. You know, maybe they look at data from a particular day or from the span of weeks or years or months. So they can explore Globe data on any time scale or from any region. So they don't just have to look in their local area. We encourage them to look around the world at how data has been collected in different areas. And then we encourage students to compare newly collected data to data that has been collected in the past. So the timeline for this year, projects will be accepted starting at the beginning of December and through the 5th of March. So now is a great time to get started. There's plenty of time to really dive into developing some research projects. We'll start recruiting judges very soon, probably more in November. So we'll start the judge recruitment process early. If you are interested in volunteering your time to be a IVSS judge, we greatly appreciate that. So we'll be sending out more information about how to get involved through that avenue. And then we will have a webinar for judges in March, right before the judging period begins. So projects will be judged the last 2 weeks in March. And then we can't wait to celebrate all of our IVSS projects on Earth Day, which is April 22nd. And in 2025, this is Globe's 30th birthday or 30th anniversary. So it's going to be a really special celebration for us. And we can't wait to provide feedback to students. We'll also have a stipend drawing for students who qualify for student research teams who qualify. And they can use those funds to offset the cost of attending the Globe annual meeting, where they will have the opportunity to present their work. So please visit the IVSS page to learn more. Here's a screenshot and a link to our page. You'll notice on the left side, there are some quick links to provide teachers and students with valuable resources, and then some other judging guidelines and things like that. You can also access past IVSS projects through our website. So we are highlighting the I am a data scientist badge to align with this year's theme. We are super excited and celebrating all of the data that has been collected over the past 30 years. So this year, in order for students to qualify for the Earth Day stipend, we are asking that they apply for and earn the data scientist, I am a data scientist badge. So to earn this badge, students need to include an in-depth analysis of data downloaded from the Globe database, as well as their own data sources if new data has been collected. In their report, students should discuss the limitations of these data, make inferences about past, present, or future events, or use the data to answer questions or solve problems in the represented system. So we've got the detailed criteria for the data scientist badge listed in the IVSS badges page, which is the link is shown here. So please check that out to learn more. But that's kind of what the meat of this webinar is to help support students and educators in accessing and downloading data to get started. So let's jump into it. All right, so on the Globe website, to get to those data resources, you'll see the quick links menu at the top. Under Globe data, you'll see a variety of options. So there's a Globe data user guide, and then 3 different ways for you to access and download data. We will concentrate on the first 2 today, which is visualizing data, which allows you to view, plot, and download CSV files of data. And I'll also show you how to retrieve data using the ADAT system. So with ADAT, you can search and download data from multiple sites. Super handy tool for accessing Globe data. The third way to access Globe data is through the Globe API. So this is a great tool for students and community members who are interested in using Globe data for programming. We're not going to get into that in today's webinar, but I encourage you to visit our website for more information about that. So we're going to start off with visualizing and downloading data using the Globe Visualization System, or Globe Viz. And this summary slide kind of highlights the features of Globe Viz, along with a screenshot here on the right showing you what the system looks like. But Globe Viz is really handy for visualizing data. Through map view, you can also look at data in a table view, or you can also plot data. And one of the really cool features is you can compare data from multiple sites and plot data from multiple sites. So I'll show you how to do that. And you can also download data as a CSV file. So let me show you how some of the features of Globe Viz. So here I am on the Globe website. As I mentioned, there are some menu options here at the top. We're going to go into Globe Data and select Visualize Data. And that brings us to the landing page here. So we're going to enter the Globe visualization system. And this is the default screen view when you start. So some things to orient yourself with are this menu on the left. So there's a nice quick start guide here that includes some links to demonstrations for how to download data, along with some tutorials. You also have the date here. So you'll notice that when you explore the system, it will automatically default to the current date. So today is October 9th. And you've got some menu options here. So before we jump into things any further, I'm going to show you how to access your own data. If you are a Globe observer, or if you have entered data into the Globe database in any way, you should be able to see your measurements or your observations when you click on this little icon of the person. So you have to be logged in, so you can see that I am logged in here. So I'm going to click here to show my sites. And then these little red dots all represent areas where I have taken observations or measurements. So if you click on one of your sites, you'll be able to see the actual measurement. So I am a cloud enthusiast, so I take a lot of cloud observations when I'm out and about. So I can see those measurements here, or those observations here, when I click on any particular site. So that's a quick way to just view your measurements. I'm going to go back to the menu here. So you'll also notice that this little arrow expands and contracts the menu bar over here. So I'm going to turn off my sites, and I'm going to show you some other features of the Globe Viz system. So when you're just getting started, you'll start with the Protocol Layers tab. Some things to notice are that the protocols are all listed in these categories by sphere. So when you click on one, it will expand the options to show you all of the different types of observations that have been entered. So these are all of the different data points or variables. So because I'm a cloud enthusiast, I'm going to show you the cloud cover observations. So in order to add those to the map, you have to select and submit. And you can add multiple observations to the system. We're just going to start with one for the sake of simplicity. And here we have the cloud observations from all over the world from today. You'll notice that there's a little legend button here in the bottom. So when I click on that, I can see the legend here. So blue is no clouds, and then you can see as we go, the darker in color is obscured, and so varying levels of cloud cover. Another really handy feature that I enjoy is you can add satellite maps to the base layers. So by clicking on the three dots up here in the menu, you can choose a variety of base maps and you can also turn on a map grid. So I am going to turn on the corrected reflectance or true color Terra map from today. Okay, so now you can see that we can see some nice cloud cover. Um, this is really interesting for today, in particular, because we've got a massive hurricane in the Gulf of Mexico that will be making landfall shortly here in Florida. So we even have some cloud observations from today for this area. So you can get some real interesting real-time data from this. So if we click on one of these observations, it will pull up the information from this site. We can see the cloud observations that have been made here. We can also look at photos, and these are really fresh and new observations that have just been made today. So, really interesting way you can engage your students in, comparing cloud observations to NASA satellite data. So here in the date viewer, you can also you can scroll between different dates or go back to different dates. We're at a really interesting time right now where we just had a hurricane hit the southeastern United States last week. So if I went to last week, around this time, we can see Hurricane Helene here is, covering the southeastern United States and cloud observations that are associated with that. So just in time learning, lots of interesting observations that could be made using these different data features. So I'm going to turn off the satellite view there, and I'm going to go back to our protocol layers, and I'll show you one other observation that I find very interesting along with cloud cover as well. So I'm going to turn off the cloud cover layer, and I'll add another interesting observation here, which is tree photos. So tree photos are fun for learners of all ages to explore. So I'm going to select the tree photos that have been uploaded for the past year. And you know what? We can also just include tree height for fun, although that might slow down our loading time here. Oh, there we go. So I'm zoomed in on the US right now. I'm going to zoom out so we can see our observations from all over the world from the past year, which is pretty cool. It takes a little bit longer for our tree photos to load, but those will pop up in just a minute. And I showed you the NASA satellite view before. I'm going to turn off our tree height measurements just so we can see the images of photos. Um, Another handy feature, again, if you click on the three dots where we have our different base maps and NASA satellite data options, you can also turn on a map grid. So this plots lines of latitude and longitude as a reference point. So let's say I want to have my students compare tree heights in different trees across similar lines of latitude to each other. Students can zoom in and explore these, and you'll notice as I scroll with the mouse, you can see the latitude and longitude there in the left at the bottom of that map option. Again, if you click on any particular site, it will pull up the information for that site. In this case, we've got tree photos. But if I wanted to go to the measurements here, it will also show me the tree height and other information about this particular site. So two, two different examples of some ways to get started by just exploring and making observations with either clouds or tree height, tree photos. I am going to go back to my protocol layers and I'm going to show you an example of how to view data from multiple sites and how to plot and download that data in GlobeViz. So I'm going to go ahead and delete these layers to start fresh. And I'm going to zoom out here. All right. So it's helpful to start with a research question, or you can just, have your students explore and make or devise questions as they go. For my case, I am going to my question is that I want to compare. I want to know how summer temperatures compare between a really urban area and a more rural area. So I am going to look at summer temperatures in the New York City area, and I'm going to compare that to some areas outside of New York. And I'm going to focus in on the summer of 2023. So the first thing I'm going to do is select my protocol layer, which is daily average temperature. And we're just going to stick with one for the purpose of this example for simplicity. And again, when I select my protocol layer, it will plot all of the daily average temperatures that have been collected today. And I'm going to expand the legend here so we can compare things. So this is an interesting view. We see some really high temperatures collected from over here and then in South America and Eastern Africa. And then I'm going to zoom in on New York City. So I'm going to look at a super urban area or New York City, and I'm going to see if there are sites I can compare it to in the surrounding area. So zooming in here on New York City, I can see, so here's Manhattan, the island of Manhattan, and I can see there are two sites that collected uh, air temperature measurements from today, right near Central Park, which is pretty cool. And then I want to compare a super urban area or populated city center to something more suburban or even farther out. So these look like some good sites for me. So I'm going to go in and see what kind of data or how much data each of these sites have. So starting with this one. So by clicking on the site, it brings up the information about this measurement station. So I can see that this station is at the American Museum of Natural History on the rooftop of the exhibitions. And I can see a plot of average temperature for the past 30 days. You can change the view here by clicking on the buttons at the bottom. So I could click 1 year to see what they've collected for the past year. And I can see there's some data for the past year, but then there's a little bit of a gap. And you can also click custom to hone in on a particular date range of interest. Another very useful feature is the data counts tab. So right now I'm looking at the actual air temperature measurements. I can also look at the data counts, which tells me how much data has been collected over time. So here, again, you can see that there are different time frames. So we're looking at the data that's been collected over the past 5 years. And I mentioned that I'm interested in looking at specifically the summer of 2023. So we're in the Northern Hemisphere in the US. So meteorological summer would be June, July, and August of 2023. And if I look at that time frame here on the data counts graph, I can see that there's an absence of data. So this station was not collecting data during that time period, although they are collecting data now. So let me see if I can find another station that might give me the data that I'm interested in. So it looks like there's two stations here in New York City. There's that American Museum of Natural History that I just looked at. So I'm going to click on the other one. And here we have another station. This site is York Prep School. So this is a school. And let's look at the data counts here. And we're looking at the past 5 years of the data counts for this station. And it looks like they're currently collecting data and have been collecting data pretty consistently since 2021. And if you hover the mouse over these points, it shows you how many data points have been collected. So this looks like it's a weather station. It's collecting a lot of data. So this one looks like it will give me the information I need for the summer of 2023. So I am going to take a look at that data. So clicking on the measurements tab, And then I'll also point out that there's other information here. There's school information, site information, and if there are photos of the site, you'll be able to see them there. So going back to the measurements tab, I am going to click custom to focus in on the time frame that I'm interested in, which again is the summer of 2023. So I'm going to go from June 1st, 2023 to August 31st of 2023, and let's plot that data. All right, so I've got air temperature data. When I hover my mouse over this little plot, I can see the readings, and this looks great. This is daily average temperature measurements from June 1st through August 31st of 2023. So I want to compare this to another site. So I am going to add this data to a plot. So to do that, you've got a couple options here. The first one is to view the data in a table. The other one is to add the site to a multi-site time series plot. So I'm going to click on that. And then you'll see a new window open over here. So this is my multi-site plot viewer. So from here, now we can view a larger plot of this data, and we can add other sites to it. So just to see what this one looks like, I'm going to click Plot All to plot only the data I've loaded so far. And here you can see my daily average temperature versus time curve. Again, when I hover over these data points, it will show me the average temperature reading and the date that it was collected. So this looks great. So I've got my summer of 2023 time series plot. So I'm going to see if I can find some more data to add to this plot. So I am going to zoom out a little bit, and let's see if we can find a more suburban or even a more rural site to compare to this New York City site. So we've got this site here in Newark, New Jersey, pretty suburban or city center area, not quite as populated as New York City, but still pretty big. I'm going to take a look at this site out here in Western New Jersey. All right, so when I click on that, again, it brings up the site information for this particular site. Again, I'm going to start with the data counts tab to see how much data has been collected at this site, and also to confirm that it has the time frame that I'm interested in. So here, over the past 5 years, we can see that this station has collected quite a bit of data, including the time frame that I'm interested in, which is the summer of 2023. So let's compare this to our New York City site. So again, clicking on measurements, I'm going to click on custom to enter the date range that I'm interested in June 2023 to August 2023. And plotting that data shows us that we get a nice daily average temperature curve for this site as well. So I'm going to add that to my multi-site time series plot by clicking on that green button again. So now you can see that both of those two sites have been added to our plot for the date range that we're interested in here. So I'm going to go ahead and plot these data. And now you can see that there are two curves on the plot, which is great. Some things to notice are the temperature curves are color coded, and when you scroll over them, you can see which station it is. So this blue curve is the York Prep School site, which is in New York City. And the red curve is the Morristown Beard School site, which is in Western New Jersey. And then you can also see the legend here at the bottom that shows us that. So one thing you might be asking yourself or thinking is, we've got this temperature curve in a really populated city, New York City, which appears to be below the curve, the temperature curve for the more rural school. So one thing that you'll want to notice, and this is a great observational skill, or something that, educators might ask their students to notice, is that there are two different axes here. So on our vertical axis or y-axis, you can see there's a blue line here, and there's a red line here on the right side. So the blue line is a scaled axis for this New York City plot, and the red line is a scaled axis for the other plot. So because I'm interested in comparing these two, I want the axes to be scaled at the same scale. So if I unclick this option to use auto y-axis and then replot it, it will plot our data on the same scaled axis. So a handy feature for comparing multiple sites by putting them on the same axis. So here, this is great, and this is what I would expect for summer air temperatures with our really urban city center having slightly higher temperatures than the more rural um, setting there. All right. So some other features that you might be interested in are saving these data plots. There are a couple ways to do that. Here in the top right corner of the time series plot view, there is a link button. So if you click on that link, it will bring up a window where you can share the URL with others. So you can copy and paste this, and the data in this table will be preserved, so you can come back to it later. Another option is to actually save the plot itself as a PDF, which you can do by clicking on the little print screen. This will also allow you to print the plot. And another thing, oops, another thing you might be interested in doing is viewing the plot data. So if I click here in the time series plot, I just clicked on view plot data, and it's showing me exactly what's shown in the data plot. So it's showing me the date these measurements were taken, and then the daily average temperature measurements for those two stations. So I've got the York Prep School here and the Morristown Beard School. You can also export this data as a CSV to import it into Google Sheets or to open it in Excel. So all of the data table views will have an export to CSV button in the bottom left corner. So when I click on that, it automatically takes my data and downloads it into my downloads folder. One thing I do want to point out about that, about downloading data from the multi-site plot view here, is that it will only show us the data that is plotted here. So the date, and then the variable of interest, which is the daily average temperature for each school. It does not include information about location, such as latitude, longitude, or elevation. So I'll show you how to get that more detailed view. So another option for downloading the data is for actually downloading it within this view here, the station view. So if you click on the View Plot Data in Data Table button, so this little blue button that's above the green button, it will again bring up a data table. And this is the data just for this particular site. So the Morristown Beard School, you can see the school name, site name, and then other location information about this school. Then you'll also see the detailed temperature measurements that were taken at this station. So this is a weather station where daily or temperature readings were taken every 15 minutes. So we can see that here in this detailed view. So again, you've got the Export CSV button in the bottom left, which will allow you to download this data. So one feature about downloading here in the Globe visualization system is that it allows you to download data from one station, and it'll allow you to download one variable of interest. So this system is really handy for downloading specific data from a single station. If I wanted data from both of these stations and I wanted that really detailed information, I would need to go back to the York Prep School site here and enter my date and variables of interest and then download it through that window. All right. So just a little check-in. You might want to pause for a moment to reflect and think about the research questions or data that your students or you might be interested in exploring using GlobeViz. Or just in general, what are you interested in exploring further? And the next thing I'm going to show you is how to retrieve and download data using another very handy feature, which is the Globe Advanced Data Access Tool, or ADAT. And so the ADAT tool has some features that the GlobeViz system does not have. And those features, so I've got a screenshot of the ADAT system here. ADAT allows you to search for data using advanced filters. You can see the filter options here on the left. You can also download summary files to identify data-rich sites. So we use the data counts in the GlobeViz system. You can also do the same thing here, but you can see data counts for multiple sites at a time, which is pretty handy. And then in the ADAT system, you can also download data for multiple sites. So if I wanted detailed data from each of the sites that I just showed you, I could get it all at once here in the ADAT system. And data can be downloaded as a CSV file. So let's take a look at the ADAT system. So I'm going to head back over to our website here and clicking on Globe Data. I'm going to go to Retrieve Data using ADAT. And here's our landing page that gives us an overview of the tool. And I'm going to click on this button to enter the data access tool. All right, so I am going to demonstrate how to download data, and we're going to use the same example we used with the GlobeViz system. So the first thing you'll want to do is select some of your filters here. So to start with, I'm going to select the protocol that I'm interested in. And here in ADAT, you can see that the protocols are listed by sphere and again by variables or observations. So these are all of our protocol options. And so again, I'm going to select air temperature to show you the same example. And just to show you how you can download multiple observations at once, I'm also going to download data for precipitation here. So I'm going to add both of those to my filter. And you can see once I clicked add to filter, it put them here under the protocols. And I'm going to go ahead and apply that filter by clicking on this button. So we can see how many stations have collected air temperature and precipitation data. All right, so here we have over 51,000 sites that have collected air temperature precipitation data. So keep in mind that I didn't put any other filters on this. So this is all of the sites that have collected either of those two pieces of data throughout Globe's 30-year history. So if I clicked on obtain measurement data, I would probably get a lot of data points. If I was just getting started with my research and didn't really know where to start, I might download a summary data file if I wanted to see where the really data-rich sites are, or I might want to add some more filters before I do that. So let's go ahead and do that. So I'm going to add in my date range here to narrow that down a little bit. So I'm interested in the summer of 2023. So I'm going to enter June 1st, 2023 through August 31st. 2023, and I'm going to add that to my filter. Anytime you change a parameter here in the filter side, you need to reapply that filter. So I'm going to click Apply Filter. And now we went from over 50,000 sites to 800, a little over 800 sites that have collected air temperature or precipitation measurements in the time frame that I'm interested in. So if we download the summary data, so let's say I wanted to compare my New York sites with some other sites, I might use the summary data to help me identify which other sites have data for this time period. So here is, I'm going to show you what the summary data looks like. And so I've got my summary data in my downloads folder. I'm going to open it in Excel. And this is what a summary data file looks like. So we've got our metadata here at the top. So site ID, school name, site name. And then we have the different protocols listed. And the data counts column shows us how many data points there are for each protocol. So at this first site, there are 3 air temperature measurements for the time frame that I entered. So here we can see if I wanted to look at a site that had collected a lot of data, I might look at this one that's got over 5,000 measurements of air temperature, and then we've also got some precipitation measurements. You can also use this to look at, locations of interest. So if you're looking at a particular latitude or longitude, you can identify that here. So the data counts feature is, or the summary file is a really handy feature for finding sites that have the data that you're interested in. All right, so I know that the sites that I'm interested in, and I want to download those sites. So I'm going to go ahead and add those site filters here. So when I click on site name, I'm going to type in the name of each site. And when you start typing in a site name, you'll see the search feature will populate with everything that's in the system. So I'm going to add the York Prep School site, which was a site in New York City, to my filters. And I'm also going to add the New Jersey site, which is called MBS. And then it's on the roof of this building. So I'm going to add that to my filter. And again, after you apply or after you add a new filter, you have to click apply. And now we've narrowed down our measurements to those 2 sites that we're interested in. Again, I could download the summary data to see how many measurements are available at each site for either of these protocols. But I'm going to go ahead and download the measurement data now by clicking on Obtain Measurement Data. So when you click on that, the system is going to start to retrieve that data. So now I can see that there are over 18,000 data points between these 2 sites. And I want to go ahead and download that data. So again, I'm going to click download. And now the system might take some time to download this data. The more sites and the more data you have, the longer it will take you to download. So just a word of caution there. But I only have 2 sites, and so that was pretty speedy. All right, so I downloaded that. I'm going to find that file in my download history. So when you download measurement data from ADAT, it will download as a zip file. So to unzip it, I'm just going to double click here, and then it will allow me to open my CSV file. So I am going to open this file in Excel to show you what it looks like. And here we have it. So here, I'll just point out a few things. We're not going to go into this in too much depth, but I've got the metadata information in the first two rows here. So going from the ID associated with the school to the site name, the location information, so latitude, longitude, and elevation, the date that measurements were made, and then the specific times that measurements were made. And then finally over here in column L, I can see my air temperature data in degrees Celsius. And since I selected 2 protocols of interest, I selected both air temperature and precipitation. As you scroll to the right, you'll start to see those other protocols that you selected. So here, for precipitation, there are a variety of ways that precipitation can be recorded. So you'll see that information here at the top. Since I am looking at precipitation during summer months, we probably won't see anything for snowfall accumulation, at least I hope not. It's probably going to show up as liquid accumulation. And so if I scroll down here, I'll start to see some values populate for precipitation on various dates. So just some things to orient yourself. This data is listed by site and then by date and then by measurement. So I can see a precipitation measurement is here within the temperature readings on June 19th for this site. So we will have a webinar in November to help support educators and students with cleaning up these data files. So you probably will have to, um, eliminate things that you don't need and reorganize things to help you visualize and plot and analyze data of interest. So we're not going to go into that now. Really, the goal for right now is to help you find and download data. So here you go. This is a data sheet to help get you started. And then I'm not going to go into all these other filters, but I encourage you to explore them. You can, apply filters to help you zone in on a country or state or territory. You can enter a school teacher name, elevation range, latitude, longitude, and things like that. So a lot of advanced features here with the ADAT system. All right, so in thinking about the GlobeViz system and the ADAT system, I showed you two different ways to download data. So think about what are the advantages of using ADAT to find and download data compared to the Globe visualization system, or vice versa. Um, so just to summarize, the GlobeViz system is really great for visualizing data in map view. Also allows you to plot data, so to create some data visualizations and share those visualizations. And you can download data for specific sites of interest. ADAT offers you a little bit more advanced features for downloading data for specific sites or searching for data. So those are just, a few things, but a few things to think about based on your data needs. Okay, so now I'm going to show you how to import a CSV file into Google Sheets for further analysis. Um, if I know a lot of users use Excel. If you don't have Excel installed on your computer, Google Sheets is typically free for users and a great spreadsheet program for analyzing data. So to do that, I'm here in Google. I'm going to open my Google Drive, and to create a new sheet, you're going to select Add New, and I'm going to select Sheets, and I'm going to open a blank spreadsheet. All right, so here I have an untitled spreadsheet, and now I'm going to go to File and Import. And I have all of those CSV files in my downloads folder. So I'm going to go ahead and upload one of those CSV files. So clicking on upload, and then I'm going to navigate to that file on my computer in the downloads area. And we'll just open this globe measurement data by clicking on it. And then the default features usually work just great. So I'm just going to say, okay, import that data. It might take a moment, but there we go. So here we have all of the data that was shown in the CSV file that I just showed you in Google Sheets now. So we can clean things up, rearrange things, and prepare for our analyses. So again, the metadata is in the first two rows, and then we've got all of our detailed information here. So as I scroll down, you'll see we'll go from the New York City's site to the New Jersey site. And just some other tips if you're not familiar with the Google Sheets environment, it's a good idea to rename files with descriptive file names. So in this example, I'll just say Globe data, summer 2023, New York City and New Jersey. If you are interested in sharing this data with somebody else or having a collaborator edit with you, you'll click on the little share button in the top right and then change the access here. So you can either share it with specific people by entering their names, or you can change the permissions here to share it with anyone with a link. And then you've got some additional controls over here based on whether you want somebody to just view it or edit the document. All right, so that in a nutshell is how to download data from our Globe database using either GlobeViz or ADAT. I invite you to join us in November. The date will be coming soon for an upcoming webinar for help with preparing your data for analysis. So as you can see in the spreadsheet and the CSV files, there's a lot of information. You might need to rearrange things to help get you started in analyzing your data and creating plots and analyses. So we will be here to support you and answer questions with that. But hopefully you've gotten some ideas for ways to get started and exploring data in our system. And I do want to point out that there are a lot of resources on our website to help support you with data. So if you visit this website, you'll reach our tutorial center, which has short video tutorials for the GlobeViz system, also for the ADAT system, and the API resources, which we did not go into. And if you are looking for resources to just help support your students in exploring globe data, we have a lot of those as well. So just a couple to get you started. My NASA Data has some excellent resources to support educators and students in primary through undergraduate or high school grade levels in analyzing and interpreting NASA data. And they've got some great visualization tools for exploring NASA data. In addition to that, they have globe connections that link to these explorations. So I encourage you to check out My NASA Data if you have not explored those resources. We also have globe data explorations, which include activities, learning activities to help students learn how to analyze globe data while also learning atmospheric science concepts and geography. So those are some really great resources to use in your classroom. And then finally, for younger students, Elementary Globe is a fantastic resource which takes a storybook approach to teaching concepts about Earth system science. And there are also learning activities that go along with those storybooks to help students better understand those concepts and to explore globe data. So this is a great launching point for educators at primary and middle school grade levels to engage their students with learning about globe. And then we will have some upcoming webinars to further support you. As I mentioned, we'll have a webinar in November to help you prepare your data for analysis. And then we've got some great field campaign webinars. The next one's coming up on the 23rd of October. And that one will introduce you to the Globe Data Campaign. We also have some student presentations that will be coming up in October. So please check out the 30 Years of Globe Campaign website to learn more about upcoming webinars there. And then some common questions that we've received for the 2025 IVS. The first one, do students have to use data from the Globe database in their projects? And the answer to that is we welcome, all student projects who are exploring Globe, either collecting data or using past Globe data. But to earn the data scientist badge, students need to access and analyze data from the Globe database. And we will have a stipend drawing on Earth Day to help offset the cost for students in attending the Globe annual meeting, which also provides them with an invitation to present their work at the Globe annual meeting. In order to be eligible for that, they need to earn the data scientist badge. And we talked about this earlier, but what if data are not available in my area? So we encourage students to explore data collected by Globe community members in different parts of the world, or they can also collaborate with Globe partners and classrooms in other areas to share and discuss data. In addition to that, we encourage students to use other sources of Earth system science data, including local data sets for comparison. Do IVSS projects need to include newly collected Globe data? We definitely encourage students to explore their local environment, using Globe protocols, but it is not a requirement for the IVSS. Students may use previously collected data in their IVSS investigations. And then finally, how can primary school students engage with Globe data? And I pointed out some resources for primary educators. We encourage you to use the Globe visualization system to guide students in making observations and asking questions, to discuss Globe data. And then we also have the elementary Globe resources that are a great launching point for exploring Globe data further. And then finally, if you're interested in having your students or you yourself collecting data, there are a lot of campaigns that are happening right now. So we invite you to join a Globe field measurement campaign. We talked through the 30 Years of Globe campaign, but there's also the Trees Around the Globe campaign, and then the North American and European phenology campaigns, Globe Mission Mosquito, and the Urban Heat Island Effect Intensive Observation Period. All of these are happening now. You can download these slides from the IVSS page and access these links directly. But all of these hyperlinks will take you directly to our website where there are a ton of resources for all of these different campaigns. So a lot of opportunity for educators, students, and community members to get involved and collect your own data. And that is the conclusion of this presentation. Please check out our website for the recording of this presentation in addition to the slides that will walk you through all of the features of the data visualization and downloading systems that I showed you. If you have any questions at all, please feel free to email ivss@nasaglobe.org, and we will be happy to assist you and answer those questions. But we can't wait to see what students explore in their IVSS projects this year using past Globe data and exploring their local environment if they're collecting data. So thanks for joining us, and we will see you next time.